Hello students, welcome back. In this video, we're going to introduce a mechanic expansion to Bot Bash Arena. Right now we have a heat system and we have a weapon system and we have this aura, this green circle around us and an enemy system, but they're all sort of independent. In this video, we tie them all together through something that we will call heat capacity. Our enemies right now can't deal us damage, but in this video, they're going to be able to collide with us as they track us, and if they hit us, we will lose some of our aura. Our green aura that surrounds us will get smaller and smaller and smaller. As that happens, our heat capacity, which is the new mechanic of this game, is going to go down. We're not going to be able to generate as much heat. So if you remember, our little heat meter is that red circle that fills out, and once it hits the edge of our aura, we've overheated. Well, if that aura shrinks and shrinks and shrinks, our heat capacity is going to go down. That red circle is not going to be able to grow as much. So as we lose aura, think of that as like our health, not only are we closer to dying, but we overheat faster. So there's going to be levels of complexity in this new mechanic expansion of heat capacity. So let's head to the computer screen and let's dive right in. Let's tie all these systems together here in lesson number 7, our mechanic expansion of aura and heat capacity. So I have our starter file open here in vscode.dev. I'm going to minimize that file though and open the file directly into my browser so I can see what I'm doing. So let's take a look. Here we have it. All right. So you can see up in the HUD we have heat load 0%, aura 100%. All right. And it looks like my heat system is broken. I'm not generating any heat right now. And I'm not taking any damage. We said that if I get hit, I should take some damage and my aura should shrink. So the system is not working, but you know exactly what we're going to do. We're on lesson 7 now. We're going to fix that system in this video. So mission number 1, it says add the aura and hit system constants. So hey, we're adding a new system to our game. We should probably add some constants that we can use to control or tweak the system. Little tiny knobs that we can turn to change how that system looks, plays, or feels. So here we have our aura constants. We're going to add the aura and hit system constants. We're going to control how much damage we're dealt, how much we regenerate, and knockback behavior. So think of knockback as like anytime an enemy hits me, it's going to send me flying in the opposite direction of the enemy. And that's going to give me like a bit of a cool effect where I get hit. It's almost like I'm colliding and I'm getting pushed away. So let's look at this system. It looks like we got quite a few different parameters or things we can set here. First is how much damage are we going to take to our aura when we get hit? Well, right now it's set to 1. Well, that seems very forgiving. Let's up it. I'm going to set it to 12. We'll take 12 points of damage. And I think that's pretty good because what is our aura originally? We're going to figure that out here in a second. Oh, it's based off of, that's right. It's based off of our diameter. So it's our player's diameter. Aura diameter max is set to player radius times 5.5. So what's 18 times 5.5? Let's take a look. 18 times 5.5 gives me 99. All right, so it's basically like 100. So we're basically starting our aura diameter at 100, and then we're going to take 12 points of damage to our aura every time we get hit, and our aura radius will get 12 pixels smaller and smaller and smaller and smaller. That's the goal. Now, when will we die? So there's got to be a certain diameter of our aura when we are going to die. So as that aura gets smaller and smaller and smaller, I want it to die when it is the exact same diameter as the player. So that's when we will no longer visually see it. So let's set that to our player radius. That's the size of our player, but I want the diameter, so I'm going to multiply that by 2. Now, every time I kill a bad guy, I'm going to restore some aura. So how much aura am I going to restore every kill? I'm going to restore 0.0025% of the aura. So that's a percentage. So basically 0.25%. So every 4 kills, I am going to restore 1% of aura. I think that's pretty fair. All right, and now we've got some constants here for our knockback behavior. So when we get hit, we're going to have a cooldown in seconds. So we just can't get spam hit, right? We're not going to get hit. We're going to have a little bit of cooldown. So if we get hit, we're going to set a cooldown timer to, I'll do 0.75 seconds. And so that means I will be invulnerable for 0.75 seconds. Nobody can damage me. So that gives me some time to respond to the hit. And then when we get knocked back, we're going to have a knockback speed. And this is going to be in pixels per second. And I'm going to start it off super high. I'm going to start back a knockback at 1,520 pixels per second. And then we are going to dampen that. So we're going to start super fast. And then we're going to slow it down. So that's going to give like this huge, we'll say, impulse. It'll look like we're really changing our speed, and then it's going to slow down. Dampening is the rate at which we slow down this speed. Now, higher numbers means faster the stop, and I'm going to set it to 4. I think these numbers work pretty well for me when I tested it, but we can always come back and check it out and see if we like it, if we don't like it. All right, let's go see what else we got for this aura system of damaging our aura, building our heat capacity. If we look here, it looks like I've got some variables. I got hit cooldown in seconds. So this is like our timer. We'd set it to 0.75. We're invulnerable, and then we'd start decreasing it, 0.65, 0.6, 0.55, 0.5, 0.45. When it hits 0, it means we can take damage again. I've got my knockback velocity in the X direction, my knockback velocity in the Y direction. And then I've got these variables called heat capacity and heat load. And so these are going to be a measure of how much, so when we first start our game, our heat capacity is going to be at 100%. And then as we take damage, that heat capacity is going to drop. We're not going to be able to hold as much heat as our aura shrinks. And then our heat load is a measure of how much heat we have relative to our heat capacity, how much heat we can carry. So we'll look at those a little bit more, I think, in a mission where it will become hopefully a little more clearer if it's not yet. All right, let's go to mission number 2. What do we got here in mission 2? Mission 2 brings us to reset game to defaults. It's all about the aura state setup. We got to set the state for aura, heat capacity, and our knockback state. We're going to reset all of those variables at the start of a game, because when we start our game, I definitely want to take, let's do our knockback first. So I'm going to say, hey, hit cooldown seconds. I'm going to set it equal to 0. If there was time on that timer, we're going to set it to 0. And then if we had some knockback velocity, like if we had just gotten hit and we were being thrown across the screen, when we start the game, we got to take the knock velocity in the X direction and set it to 0, and the knock velocity in the Y direction and set it to 0. So knock Vx, knock Vy are 0. And then we're going to target our heat and aura variables. So we looked at heat capacity. When we start our game, I'm going to just say, let's set it to 0. And then we'll set heat load equal to 0. All right, and I'll put some comments here to maybe help us understand what this is. So heat capacity is the current safe heat limit based on aura size. And heat load is going to be how full the current heat capacity is. How full the current heat capacity is. All right, so we'll work with those coming up here in a little bit, but we reset them. Perfect. So now let's go to mission number 3. We got to take damage. All right, this puts us in a collision function called check player enemy collisions. All right, let's go check to make sure that this function is getting called, much like check enemy bullet collisions. So we're checking for collisions. This time, not between the enemy and a bullet, we're checking between the enemy and a player. And so here we have it. They are in our draw function. So we are checking these every single frame of the game. And what do we want to do? Well, if we look here, we loop through all of our enemies. So for const enemy of enemies, we determine how far away our player and enemies are in the X and Y direction. We get their hit zone. And then we use the Pythagorean theorem to determine if a collision has occurred. And we've looked at that math, I think, in our previous video and one of our previous videos. We set that math up. So now, if there is a collision, right, if the distance between the player and the enemy is less than the hit zone, we want to deal some damage to our aura. And the way we deal damage to our aura is we target the variable aura diameter. And we want to decrease it. So I'm going to do minus equals. And how much do I want to decrease the aura diameter by? Well, I want to decrease it by a constant that we had set for our system called aura hit damage. What is it? It's like 12? Yeah, it's 12. Perfect. The only problem is we're decreasing the aura, so we're going to reduce its size. It's going to get smaller and smaller and smaller. I want to make sure that I constrain it because I don't want it to get too small. So I'll say aura diameter is equal to the constrain function. What do I want to constrain? My aura diameter. And I got to set the minimum value and the maximum value. Now you might think, okay, 0. And then what is our maximum value for our aura? I don't know. Let's go check our constants. What do we got? Oh, we got aura diameter max right here. We had defined that. Yeah, so that's definitely going to be our maximum. But our minimum is going to be not 0. Don't we have, what do we have? Yeah, we've got the aura depth diameter. So that's going to be our minimum. That's the size of our player. We don't want it to go smaller than that because if it does, it means we're still playing the game when we should have died. So let's set, instead of making it 0, we'll set our smallest diameter for our aura to be aura depth diameter, tab to autocomplete. And our largest value will be aura max, aura diameter max. So this second value right here, tab to autocomplete. All right, so with that, we should be able to start taking damage. Let's see if mission 3 gives us some damage. I'm not going to like it. I'm not going to want to take damage, but let's see. I get hit. Whoa, where'd my aura go? It just completely disappeared. Well, that's because we have not implemented a cooldown yet. So let's look at mission number 4. We took that damage, and then the next frame, the player was still applied to us in direction. So we are going to look at missions 4 and 5 together to fix this problem. Mission 4 says apply knockback movement to the player. So we know we have this knockback velocity, and this is going to be in our update player function. All right, so let's figure out what we're going to do here. I think before we do that, I got to go look and see what else were we doing in mission 3 because we got hit. All right, so we got hit, and then we checked to see, all right, we're checked to see, all right, what is the length of this? So we get our length variable, which is the square root of dx squared plus dy squared. Essentially, how far away are the center of the player and the enemy, all right? And then we're just making sure that they're literally like not right on top of each other, as long as they're just slightly off. So what does that mean? As long as like the collision happened like, what, like this? So here's my player, right? And here's my enemy. So maybe the collision happened like this. Boop. And so we get that length right there. Or maybe the collision happened like this. So we get that length. As long as that length is not, as long as the length is greater than 0.0001, meaning they're not directly on top of each other, we can determine the direction of that hit. And look, here we are getting the directions again, nx and ny. We're getting the directions of that hit, and then we're using those directions, the portion of that arrow that lies in the x direction, the portion of that arrow that lies in the y direction, and we're multiplying by our knockback speed, which is this huge number, 1,520 pixels per second. And we're setting that to our variables knock vx and knock vy. So now we got to use that in mission number 4 to actually apply our knockback movement. All right, so let's take a look. In mission number 4, we're in the update player function. So we update the player based on keyboard movement right here, updating the player's X position and Y position. But now we need to update their position based on the knockback velocity. So in the X direction, I'm going to take that knockback velocity, knock Vx, and I'm going to multiply it by dt, just like we did here. So this already has a direction and speed built into it, right? So direction and speed, and then we multiply by time. Direction and speed, right? Let's just verify this. Direction and speed. Yep. Direction, nx, and speed, knockback speed. All right, so now we got to do the exact same thing for the y direction. So let's stay right here, and we'll go player.y in our update player. We're going to use the knockback velocity to send them. So we'll do knock vy times dt. All right, and so now this, let's just see what happens. This is going to be bad for us. I have a feeling this is going to be really bad, but sort of comical. Let's find a bad guy. Boom! Oh man, they are wrecking me. I can't even like get away. They have just destroyed me. And the reason why is because that knockback velocity is huge, right? It is like 1,520 pixels. And so what we need to do is once we apply that knockback velocity on the next frame, it needs to be substantially smaller. So let me kind of like go to my whiteboard here and let's look at what I'd like to have happen. So here we get, let's just to say we get knocked, we get knocked by this guy right here, right? So we get knocked. So the first frame, I'm going to go flying back. I might go flying back like this much in that direction. And in the next frame, I'm going to get a lot of drag on that knockback velocity. So I'm not going to go back as much on the next frame. So on the next frame, I might only go back by like this much. And on the next frame, I'm going to go back even less. And on the next frame, I'm going to go back even less. And by now, like I'm done moving. So that knockback, I want it to start huge and then really drop off. So if you think about it, I want the graph to sort of look like this, okay? Start huge and then really, really drop off. And this is a negative exponential graph. This is exponential decay. This is something called exponential decay. So we are going to use a negative exponential graph for this relationship. And so if we come back over here, once we apply the knockback velocity, we want to update knock Vx and knock Vy. And we're going to do this using an exponential relationship. To make it exponential decay, you put a negative value inside of here. And we are going to throw in our knockback dampening per second. What did we set it to? 4, but that's per second. So I need to multiply by dt, just like we did here. All right, and we're going to emulate that with the y direction. So negative knockback dampening per second times dt. Let's test that. So that's some pretty cool stuff. Negative exponential relationships here. Let's see if now, if we get that knockback, are they going to send me flying? Boom, and then I sort of slow down. Oh, that's really great. So I kind of get that nice coasting. So they hit me, boom, and you can see, whoa, my aura, it slowly disappeared. I love that. Look at that. My aura just drops little by little. It gets smaller and smaller and smaller and smaller and smaller. And then by now, I should probably be dead, but we haven't written that yet into our system. All right, mission number 4 is done. Let's look at mission number 5, hit cooldown. It says apply the hit cooldown to prevent repeated damage. Ensure the player cannot be hit every frame. So we've got a knockback system, but there's a chance we could get knocked into another enemy, right? And so then it's like double damage. I just think that is unfair. So we're going to put a cooldown system here. When we check for our enemy player collisions, we're going to take our hit cooldown in seconds and decrease it by dt. And then what we're going to do is say, hey, if that timer that we're in like a cooldown period is greater than 0, don't take damage. Like maybe it's set to like, I don't know, 0.75. So, oh, what did I do there? Let me stop being silly. So maybe it's set to like 0.75. So, right, we just got hit. So we set it to 0.75 and now we're going to subtract. Maybe it's 0.7. I still shouldn't take damage. It's 0.65. I still shouldn't take damage. It's 0.6. I shouldn't take damage. It's down to 0.1. I still should not take damage. But once it hits 0, then I can take damage. So what we're going to do is we decrease it and then we're going to ask a question. Is that hit timer seconds? So is hit cooldown seconds greater than 0? If it is greater than 0, return. Get out of this function. And that's not going to even check to see if we have collided with an enemy and apply our damage. So this makes us invulnerable for that time period. But once hit timer seconds gets to be negative or less than 0, then we are prepped to take damage again. All right, so I don't know if we'll really see it, but the system is in place at least now to where if I got hit, I don't get hit more than once for about a good 0.75 seconds. All right, so this is working pretty good. But what we've got to do is, you notice our heat system is just non-operational. So we got to kind of fix that, I think. So let's look at mission number 6. Mission number 6 says link aura size to heat capacity. Yeah, see, that is broken right now. And so our aura is getting smaller and smaller and smaller. And so somehow we have to link that to how much heat we can take. So if I restart my game at full, like with a full aura, my heat can grow to be this huge circle. But now after I take some damage, my heat can only grow to be this small circle. And I want to calculate the heat load correctly. All right, so this is going to be sort of interesting. We want to scale our weapon overheating based on the size of that aura. So I'm going to go to the whiteboard. Let's draw a picture here to maybe help us understand what we want to do. So I'll move up here. So let's just say I have my, I'm going to say I have my player. So here's my player, beep. Okay, so here's my player, right? Here's my player, P. And then here is the player's aura. I'll do the aura in like green, sure. And so this is the max aura. All right, so we'll say, and we'll just say that this is a value of 10. So this is max aura. This is what we started with. And then let's just say we generate a little bit of heat. So now I'm going to generate some heat. So I'm going to generate some heat. So this is my heat that's just been generated. And let's just say that this has a size of 2. All right, so right now, based off of this, if we looked at how much heat we've generated out of how much heat we could get, we would have 2 out of 10. So our heat would be 0.2 or 20%. Not too bad, okay? But we're going to take damage. So now imagine we take damage. So as we take damage, our aura is going to shrink. It's going to get smaller and smaller and smaller. And let's say our aura shrinks down to only be this big now. So the aura has shrunk. And let's say the aura has shrunk to a size of 4. So what we're going to say is we no longer can hold the full amount of heat. I can't go all the way out here to 10. I can only go out to 4. So let's define a new term called heat capacity. Heat capacity is going to be a measure of the relationship between the aura size, so the current aura diameter, divided by the max aura diameter, so the max diameter. And in our case, in this example, it's going to be 4 out of 10, which is 0.4 or 40%. So that's our current heat capacity. So how much heat can we hold? We can only hold about 0.4 or 40% of the original starting amount. So now we're going to define something called heat load. See, if we were at our full aura, our heat load right here at this circle is 20%. But our heat capacity has shrunk. So we'll say, hey, heat load is a measure of what the current heat is out of the current heat capacity. So in this case, since our heat capacity is only 4, right? 0.4, 4 out of 10, we're going to say, okay, that's 40%. We're going to do 2 out of 4, our heat is 2 out of 4, our heat capacity is 0.50 or 50%. So we are 50% of the way here in this particular scenario. Whereas if we were at full health, our full max aura, we would only be 20% of the way there to overheating. So let's try to implement these concepts here in mission number 6. So the first thing I'm going to do is I'm going to define heat capacity. So I'll say heat capacity is equal to, we said that this is going to be our aura diameter, the current aura diameter, right? Our current aura diameter divided by our max aura diameter. So we'll say heat capacity is equal to, I have a variable called aura diameter divided by, and then we had a constant called aura diameter max. All right, so there is the heat capacity. So that's set. Now, based off of that heat capacity, I will calculate what the current heat load is by looking at the current amount of heat we have generated divided by the heat capacity that we just calculated. Excellent, excellent, excellent. And so now I want to make sure that this number stays between 0 and 1. I don't want it to get too high or too low, so I'm going to constrain it. I'll say heat load is equal to constrain, and we'll constrain the heat load between 0 and 1. All right, let's take a look and see what this new system adds to our game. So now when I refresh the game, all right, our heat load is at 0%, our aura is at 100. I'm generating heat. All right, so this is pretty good. You can see it's scaling here nicely. So like right now, we're at maybe like 50% heat load. Okay, so let me take some damage. Boom, boom, boom. So now my circle is much smaller. So now when I generate, you can see 50% is a much smaller circle than what it was for my heat. So the load, I can't carry as much heat anymore. My load, my aura is getting smaller and smaller and smaller. And you can see right now I've completely overheated. Oh no, oh no. Well, I should be dead now, and I'm not yet because we have to implement that part. But it looks like the load and capacity are working really nicely here to balance how quickly we overheat based on the size of our aura, that green circle. Let's look at mission number 7. Mission number 7 says, hey, we're losing aura left and right every time we get hit, but we should have an option to regain some aura. So every time we destroy an enemy, we are going to reward the player for successful combat. So this puts us inside of our check enemy bullet collisions function. So right here, we've already gone through and we've said, hey, this is where a bullet and an enemy have collided. We're incrementing the number of enemies destroyed. We're getting rid of the bullet, getting rid of the enemy. But now what we want to do is we want to increase our aura diameter. So I'm going to say, okay, I'm going to take my aura diameter and I'm going to increase it by, what do we've got? We got a variable, I think it's called aura regen on kill, the percentage. So what is our percentage? Our percentage is 0.0025. Well, I want that percentage to be a percentage of what? I want it to be the percentage of our max aura. So aura diameter max. So our max aura diameter is like 100, I think. It's like 5 times the size of our player. And so then we're going to get that percentage of that value and add it back to our aura. And then we want to make sure we don't go too big, because if we just start adding, like right now, if we run this, if I refresh the game and I start running this and I start killing things left and right, my aura should be getting bigger. I mean, it's going to be hard to tell. It's only going to go up by 1% for every 4 kills. But it is going to be getting bigger. So that's not good. So we want to make sure we constrain it. We don't want it to get bigger than that. So let's come over here and we'll do aura diameter equals the constrain function. And we want to constrain aura diameter between, our aura, the smallest it can be is the aura depth diameter. So aura depth diameter. And the largest it can be is aura diameter max. So that just sets that nicely. All right, so let's just test this out now. I'm going to take some damage and then see if I can regain my aura. Boom, damage, boom, damage, boom, damage, boom, damage. Let's just start hitting some things. All right, so you can see my aura percentage here. Oh, I got it in the HUD. So 45, 46, 47, 48. So perfect. It looks like it's going up. It's going up. I'm going to drop that down so I don't overheat. And so now I have a system in place to regain some aura. So if I take damage, I can always get it back by just killing more and more of these bots that are swarming my way. Excellent. So mission 7 looks really good. Oh no, I overheated. Oh no, they're swarming me. At this point, I should be dead if my aura gets too small. So I hope mission 8 is all about that. And it is. It is our aura failure. So that means it's our game over condition. It says in the check player enemy collisions, if we take damage, we want to check to see if aura diameter, we've shrunk it down. Is it less than the aura depth diameter that we had stated? And if that is the case, it is time to end the game. And how do we end the game? Well, we switch to the game mode. We switch our game mode to lose. So current game mode is equal to game mode. That's our game mode object. And we're going to access its lose property. And with that, I believe our aura system, our heat capacity, it is done. Everything is tied together in this very complex mechanic expansion. So now I can start shooting. All right. I can start taking some damage. Boom, boom. Taking lots of damage. I can refill my aura. All right. The smaller my aura, the less heat load I have. My heat capacity is much smaller, so I fill up my heat load much quicker. I reach that maximum heat at a much faster rate. And if I keep going, I'm building that aura back up, but I take another damage. I take some more damage. When my aura hits 0, it is a critical system failure. All right. So I think this is a great place to stop. This was a pretty involved expansion of our mechanic. It's almost like we took like multiple systems and have intertwined them so they are all related, right? Our aura system, our heat system, our shooting system, they are our enemy system now too. They're all tied together to really create some complex, fun, and rewarding gameplay if you nail it just right. So I think this is a really good place to stop, and I will see you in our next video.